In this lesson, we're going to look at factoring perfect square trinomials and, and look at how to factor the trinomial into two binomials and then a binomial squared. But before we look into that, let's go back to something we've completed before, where you were given, let's say for example, x plus 5 squared. This is before in the previous section of multiplying polynomials, where the question we have, x plus 5 squared, the exponent of 2 is telling us to multiply x plus 5 twice, and then we're going to FOIL. Take the x, distribute twice, we will have x squared plus 5x, and then we're going to take the 5 and distribute twice, where we have 5x plus 25. Then we notice that the middle terms are identical, and we're going to add those, and we have x squared plus 10x plus 25. Well, we're going to take now this x squared plus 10x plus 25, what was the answer, now becomes the question, and we're going to be working backwards, and we're going to work towards the binomial squared. But before we do that, we have some rules on how to recognize a perfect square trinomial. First things first, you have to have, or there must be, 3 terms. Also, the first term and last term must be perfect squares. So let's look at the first question that we have that's listed. Number 1, v squared plus 8v plus 16. So far, we have 3 terms. The first term being v squared, the middle term being 8v, the last term being 16. The middle term that we have listed is from the FOIL, the outer and inner terms, when we will add those together. So we have 3 terms. We can check that off. The second bullet, the first term and last term must be perfect squares. Well, we have a first term v squared being a perfect square because you can find 2 identical factors that would give you v squared. And then we have the last term of 16 where we can find 2 identical factors that would give us 16. And then lastly, there must be a positive sign in front of the last term and first term. So we identify those, and as we in this last bullet being, there must be a positive sign between, in front of the first term and in front of the last term. So we have those, then we can FOIL. So as with any trinomial, we're going to set up our template, our 2 sets of parentheses, and remember our sign rules. The sign of the last term here is positive, so we're going to have the same signs. And remember, whenever we factor a perfect square trinomial, the signs are going to be the same. That goes in line with the outer and inner terms being identical and being the same. So we're going to have the same signs. For example 1, we're going to have 2 positive signs. Then we're going to break down the first term, placing those factors there. What two factors would give us v squared, which would be v and v. And then the last term, the factors we're going to put into the last term in each parenthesis. So what times what two factors, when we multiply those together, would give us 16, and that would be 4. So now we have two binomials that are matching, and that's what we want. We're going to write it as a binomial squared, meaning in exponential form. So what's being repeated? The v plus 4. How many times is it repeating? Twice. Now we can check our work to verify if this trinomial is a perfect square. Here we have v plus 4, the quantity of v plus 4 squared. To check your work, multiply, and I answer, look at your answer, and I'm pointing to it. Multiply the first term, which is v, to the last term, which is 4. We have 4 times v, which would give us 4v, and then we're going to double that, meaning we're going to multiply that by 2. And as we multiply 4v by 2, that would give us 8v. Let's rewrite that over. And notice that us checking our work, the 8v matches the middle term of the question, example number 1. Okay, so let's move on to example 2. We have 4a squared minus 2a plus 9. We have 3 terms. The first term and the last terms are perfect squares because we can find 2 identical factors that would give us that. And then we have a positive sign in front of the first term. We have a positive sign in front of the last term. So using your sign rules, let's set up the template first. Our sign rules. The sign of the last term is positive, so we're going to have the same signs. Same what? 2 negatives. And then let's break down the first term. What 2 identical factors that would give us 4a squared? 2a, 2a. And then what 2 identical factors that would give us 9 for the last term? 3 and 3. So now we have 2a minus 3 times 2a minus 3. We can write it as a binomial squared, and our solution is 2a minus 3 squared. Example 3. We have 25x squared minus 20xy plus 4y squared. First and last terms are perfect squares. We have 3 terms. First term and last terms are positive, so let's set up our template. The sign of the last term is positive, so we're going to have the same signs, same negatives. Break down the first term. That would be 5x, 5x. Break down the last term. We have 2y, 2y. And then let's write our answer, 5x minus 2y squared.